mole of a water molecule, H2O. How would I even begin to know what the mass is of 1 mole of the water molecule? Well, I know that if I were to look at the periodic table, I know that 1 mole of a single oxygen, just one mole, not the way it exists in nature, but just a single oxygen element, would be around 16 grams. Okay, and I know that, for example, 1 mole of hydrogen, not as it exists in nature, just a single hydrogen element, 1 mole of them, would be about 1 gram, right? But in water, I have 2 hydrogens and 1 oxygen. So I'm going to have to say, okay, I have 2 hydrogens. This is 2 grams. So I have 2 here. I'm going to multiply this number by 2 because I have 2 of them, and I'm going to get 2 grams total. And I have 1 oxygen. So I can take this and add it to this, and I get 18 grams. In 1 mole of water, I have 18 grams. That's how much the mass of it would be, okay? This is really, really, really important, and the first step of your homework is going to be practicing this and realizing that, look, it's always 1 mole. Did you notice how it was always 1 mole? However, the masses should be different depending on 1 mole of what? Do I have a dozen oranges? Or do I have a dozen tomatoes? Or do I have a dozen markers? The mass should be different. Where do I get that mass from? I get it from the periodic table. If I wanted to know, I'm going to look at the periodic table and I'm going to see, for example, hydrogen, it'll say 1.001 on the bottom, okay? Now I care about only the number on the bottom right now on the periodic table. This number is called the molar mass. Molar mass. Okay? It is, this number is the amount in grams that would be in 1 mole. It doesn't mean in 1 mole as it exists in nature. Again, hydrogen exists in nature as H2. So if I asked you for what the mass would be of hydrogen in its elemental form, what the molar mass would be, you would have to tell me it is actually 2 grams. You would multiply that number by 2 because hydrogen is 2, okay? So this is going to be the first part of your homework. I'm going to ask you to give me the molar mass, أولاً first, of just some elements, you know, magnesium, calcium. Look it up on the periodic table, okay? Secondly, I'm going to ask you to give me the molar mass in some compounds. For example, I don't know, sodium chloride in a molecule like water, carbon dioxide. You can do this. Just remember, all you have to do, for example, carbon dioxide. Oh, I'm writing it my way again. Carbon dioxide, okay? How much does the carbon weigh? Carbon weighs 12, and now I'm going to start using the units properly. I can write it like this, 12 gram/mole, gram per mole. Again, remember, because what I'm saying is in 1 mole of hydrogen, or for example, 1 mole of oxygen, 1 mole of carbon, in 1 mole of anything, you see how I put that equal sign. And in chemistry, I can, let's say that okay, let's do a little algebra just for those of you who aren't going to be able to remember this. If you can remember what I did about the fraction, then go for it. Otherwise, look at what I'm doing. Let's say in algebra, I've got 2 variables, okay? I have the grams and I have the moles of hydrogen, okay? Now, I want to solve for one, here, I'll do it with this one down here. I'm going to do this here. Now, I want to solve, let's say I just want to get the number 1 on one side of my equation, okay? I want to isolate, you know, I want everything on one side of the equation. In math, I'm going to get rid of either I'm going to get rid of the 2 grams, I'm going to divide by 2 grams, or I'm just going to divide by 1 mole. Now in this case, I'm just going to divide by 1 mole because that's what convention is. So I'm going to divide by 1 mole of H2 on both sides, 1 mole of H2, and what do I get? I get 2 grams per mole. Okay? of hydrogen, obviously. It's hydrogen I'm dealing with. You get it 2 grams per 1 mole, 2 grams per mole. So that would be how you write it when you write your answer. Carbon, you look it up on the periodic table, you're going to see around 12 grams. Again, I'm rounding because I don't have the periodic table with me. If you wanted to be particular, you could write 12.01 grams or whatever. Per, that's what I say, the word per. Oh, let me write it this way. Per is what I say, and I mean slash, I mean fraction, per mole. Now, I also have 2 oxygens, and I know that oxygen is 16 grams per mole. However, I have 2 of them, okay? So I'm actually going to need to multiply this number by 2, all right? So what I'm really going to wind up with here is what is 2 times 16? Excuse me, what is 2 times 6 is 12. 2 times 1 is 2, 3. So I have 32 grams per mole plus 12 grams per mole, okay? So that's what, do I know how, does that look like a 4? Okay. And then 1 and 3, there, that looks like a 4. So my answer is the molar mass of carbon dioxide is 44 grams per mole. Okay? That's how you do that again. That's going to be one part of your homework. Why do you think I'm making you write it like this as a conversion factor? Because we are going to be in the next step, we're going to be actually using that conversion factor. We're either going to be saying 44 grams in 1 mole like this, or 1 mole, here I'll put CO2, or 1 mole of CO2 over 44 grams. We are going to be converting more things just like we converted using Avogadro's number in the last video. But I'm not going to do that step yet. I want you to just know how to calculate the molar mass of anything, whether it's a single element, an ion, and again, if it is an ion, let's say it's sodium Na+, okay? I still use the 23 grams per mole that I talked about before. Why? Because electrons, remember how we said that electrons are so lightweight. For example, if this tomato was the nucleus of my atom, it has the protons and the neutrons in it. That is the weight that I'm measuring in this number on the periodic table. Then the electrons are floating around in a cloud all around it, like you guys did in your models, okay? But the weight of those electrons is so insignificant, it's so small that I don't even measure it. It's basically like saying, you know what, if you were to weigh yourself in the morning, okay, right after you took a shower, you're nice and squeaky clean, so you weigh yourself to see how much you weigh, okay? Then at night, pretend that you did nothing different the whole day except that you got a little bit dirty, right? Now, or let's say you didn't take a shower the very next morning. You're probably going to have some bacteria on your skin. Do you think that the bacteria on your skin is going to change the scale at all? No, it's not. It is such a small amount of bacteria that it's insignificant. You're not even weighing it. You don't say, my weight plus bacteria growing on my skin. No. First, that's disgusting. Second of all, it doesn't matter anyway. And that's why we don't care about the electrons. So if I were to try, to tell you the sodium ion, it doesn't matter. You still look at the periodic table. You take the exact same molar mass. It doesn't change a thing. Okay, just keep that in mind. And that's it. Now you're ready. After you watch this video, you're ready to get started on the homework. You can probably do the first few questions, and then when you see the next topic, converting from molar mass to moles, then you're going to have to watch the third video. All right, good luck.